Hello, my name is Iñaki Larreta, and I am going to explain the data analysis tools that we have developed in the Urbanite project for the use case of Bilbao. So in order to access the data analysis tools, the first thing that you should do is you should log in into the platform. Once you log in, you can access the data analysis by choosing this tab in the menu on the left side, and you will see that there has been developed 7 different analysis tools in the case of Bilbao. The first one is related to a traffic prediction. This tool aims of producing predictions of the flow at the different locations where in the city, the different locations in the city where the sensors are located. For instance, we can select one of these locations. The locations are marked in the map with blue dots here. We can choose one of the sensors. In this case, is the 290 sensor, and we can actually produce new models in order to perform predictions. All the models that have been already created within the platform are shown here in this table. We can actually filter in order to visualize only those models that we have created for the sensor selected within the map. And you can see that we have in this case is 5 different models for the same sensor, and the difference between them are the number of features that are labeled here, the number of features that are used in order to train and to perform finally the prediction. To build a new model for a given sensor, you have to select the sensor in the map, and you have to click here in this button, new model, and then a new window is open. And what you should do is you should select the number of features that you wanted to consider in order to train the model. For instance, the options are to consider the hour of the day. The second option is to consider the hour of the day and the day of the week. School and school holidays and bank holidays can be considered also in training. And also the fourth case is with meteorological variables in addition to the previous one. This consider both temperature and precipitation. And the final one consider all the previous ones, and in addition to the football events. So we can choose, for instance, the hour of the day of the week, and the school and bank holidays. We can submit it, and during the process of the training process, you can see that it will appear that the status of the model is -1. That implies that the model is still not ready to be used, and it's only when it changes to 0 is going to be able to use. Now it has been fully trained, and the model is ready to give predictions. So for instance, we can choose it, then this one that we have created. We can choose a day. You should consider that if you are using meteorological variables, we are using meteorological predictions, and that implies that only in the next 4 days is going to be able to produce a prediction. In other cases, you can choose the day that whatever day you want. For instance, we can choose that we want to have a 4-day prediction. It's telling us that it's doing a slight correction, so it's going to start tomorrow, the prediction, and this is the prediction. So this is next day is Tuesday, this is Wednesday, Thursday and Friday, and the last day here is Saturday, that has a very clearly different profile in the flux. The flux is measuring number of vehicles per hour, by the way. Other things that you can see in this particular module is that you here in this table you can have statistical values for the how do you call the different sensors. So if you change the sensor, you are going to get different statistical values, like for instance the number of measurements in the platform, average flow, maximum, minimum, and so on and so forth. More things that you can do. I mean, let me. So if we produce again the the prediction for the next 4 days, I remind you that we are still doing the for the 290 sensor. You can actually download the data, so you want to further analyze it with your own tools. The other thing that you can do is you can visualize all the labels, and in order to be able to identify better what are the identification numbers for the sensors within the map. So that's things that you can turn on and turn off. There's also a help button where you can actually get help on this information on the particular model. That's something that you will find in the rest of the models. And very important also is this reload button while you are training. Just if you want to update the table, in this case is the model, the artificial model the table that we have here. You want to update it, you should click over here. Okay, so let me jump to the next module. This is the ODI matrix computation, the ODI matrix prediction module. This is for the bike system. This is the rental system within Bilbao. This service has like these locations where you can actually rent a bike. So the trips that you have you find from the bike systems are trips that are connecting these points. In order to compute what is the ODI matrix for this service, we have considered these areas, the following areas, which are the districts areas. Let me submit this, and you will see, you can see here, this is the 8 areas that we consider in this case in order to produce the origin destination matrix. Okay. In the same way as before, you can actually click in the new model here, and you have the same features as in the traffic flow prediction. You can click, for instance, consider meteorological variables, you submit it, and if you press the reload button, you will see here how it is being trained. In this case, we have 3 different features, including the meteorological variable. We already have trained another one considering the hour of the day, and we can actually ask it for the prediction for what are going to be the values, the prediction for the origin destination matrix for the next 4 days, for instance. You will see here that in this part of the module you see the actual matrix. This implies, for instance, here are the trips that start in this area and end in this particular area, but so number, for instance, 4 to 6 will be the trips that are starting in this particular region and is going to end at the city center here in the Indauchu district. And here you get what is the prediction for the number of trips per hour that is going to happen starting tomorrow. This is for a different component. You get a different prediction and so on and so forth. Um, The same way as in the previous one, you can actually press the help button in order to obtain help in how to use this one. And you can also move this slider over here, and it's going, so you can select what day do you want to visualize the result, and it's going to show you all the metric at once. Here in the figure, in the graph, you're only going to see the evolution in time of one of the components. We press reload. We can see here, for instance, that the other model that we have trained has finished because the status is already here 0. And here in this part, in this figure, when you are not visualizing what is the evolution of the prediction in time, you are going to be able to see a rough estimate of the historical trips that have been considered in order to train the model. Okay. The next one is also related to the bikes. The next module is also related to the bikes, and in this case, what we are doing is analyzing the trajectories, and in particular, we are aggregating the trajectories in order to show what are the most popular points in the map here where the trajectories pass by. So the darker the point that is depicted here in the map, the darker it is, the more popular, more trajectories go through these points. So what we have performed here is we have matched every trajectory within of the traffic service of the rental service into the map. We have aggregated those trajectories together, those points together. So for instance, here we can see that we have a lot of trajectories going through during this along this area. This is the museum site, and we can see how this changes when you change the date. So for different days, you have different number of trajectories going through, and so on and so forth. This is if you want to visualize the on a given day what has happened, but you also can just click here and select the type of day and if you want the one day on a week, if you want a Monday, Tuesday, and so on and so forth, or what part of the day that you want to visualize, if you want in the morning before 1, or if you want in the afternoon after 1 p.m. You can download the points and the value, or upload the result that you are visualizing into the data storage, the Urbanite data storage for data analysis. You also have here a help button that is going to tell you how to interact with the model. The next model is not related to bikes anymore, to the bike service, rental service. This one is related to the bus service in Bilbao. And what it does is analyze, or it computes the origin destination for matrix for the bus service. In particular, more specifically, what it tries to solve is it computes where is where the people disembark from the bus, and in order to compute this, that's something that is not recorded by the bus itself. So it uses the smart data information, the smart card data basically. We process it, and basically what we perform is compute where are the most likely locations for the where people get off from the bus. So for instance, for a given line, it has two modes of operation, the per line and per trip. I'm going to start explaining the per line case. In this case, you can see here in the map, you have what are the locations of the different stops for this particular lane. And if you actually locate your the mouse button here, you could see where are the most likely bus stops where the people get off for people who actually get into the bus in this 1605, for instance, bus stop. And the same information is actually shown on this area of the module. So this actually gives a pretty good idea on where are the locations where the people that jump into the bus at a given stop actually disembark. I have to mention also that in the case that the module is not able to compute to give a result, actually gives you backwards a negative value for the bus stop, which is not a low value. The other mode of operation is the per trip mode. In this case, we are considering that in a trip, the passenger could change buses. So it's going to change, it's going to connect with a different bus line. And in this case, what you do is you can actually click on one of the bus stop, and it's going to tell you where the trips that start in this bus stop are going to end. Okay, as you can see, when you select one of the bus stops, it's going to show you what are all the bus lines that go through that given bus stop. But there is still locations, as you can see here or here, that are not connected to this particular bus stop by any other one. That implies that in order to arrive to this one, to this bus stop, there has been to be a transfer. So that this way we can identify areas, we can identify places that are connected to the previous bus stop, and this could indicate that maybe is interesting to have a bus line that goes through that connects this point location with this other one. The next module is related again with the traffic prediction, and this is also this actually is going to use the artificial intelligence models, the prediction models that we had trained in the previous one, in the traffic prediction one, but it's a different way of visualizing the same results. So, for instance, for a given day, in this case, we are considering a Monday that is not a holiday, it's actually a school day, and mid-temperature and a dry day. There is no soccer game today, and we are going to consider the hour of the day and the day of the week features, okay? So we can load the data here, and once it has been loaded, we can actually change the hour of the day, and you can see with different colors what are the predictions that the prediction models are producing. If you are interested in visualizing what is the result, you can actually click on one of the links and you can see what is the prediction for that sensor. So for instance, this one or this one. These are the SAC predictions that we are performing in the previous module, but the way we specify the input is not related to the next days, the following days, but you can specify the data you want to see, and you also have the ability of visualizing the prediction for the whole city with this color scheme. The next module is related to the noise computation. This module has also two modes of operation. The first one is by just considering the specifics of the infrastructure, the specific of the roads, how wide are roads, how important are the different roads within the city. And the other one is by passing by uploading into the module a given traffic simulation produced by Urbanite. So I'm going to show you the first mode of operation. In order to do that, the first thing that you should do is generate a map. You want to choose a piece of the city in order to do the computation, and this is needed because the computation actually uses so much memory and so many computational results that you want to be more concrete and specify a small piece of the city. So in order to specify the area where you want to compute the noise, you can click here in new map, and by clicking over here, you can actually select an area of the city here. You should give it a name. In this case, I'm going to call it Abando, for instance. Submit it into the platform. If you click here in update, you will see that now we have a second map available here, and we can use this one in order to perform the noise computation. Um, well, once you select it, you have to give a name to the computation. I'm going to call sim2. You click create, and once you do that, if we click here update, you can see that we have two simulations. The one that is called sim1, that it has already finished because the status is 0 here, and that is in the Mojua, using the Mojua map. And the second one that is labeled with -3 yet, meaning that is still in process and it will take a while, using the new map that we have created, that is with the abandoned map. Now, if we want to visualize it, and I want to stress the point that in order to visualize it, you should see here a 0. Let me update. See, it's still in process. Now it's -2, but we are going to visualize the previously computed simulation computation here. We can click here, and you see the result of the simulation here. The brighter the color, the more noisy is one. Right now, we are visualizing the units are. This is measured. The noise is measured in dBms, and the brighter is the higher the value. Important to notice that this is the visualization is performed for 63 hertz. You can actually download, if you want, this GeoJSON in order to process outside this tool, or you can upload it to the data storage, or also get help by clicking here in the bottom. The last module that I want to talk about is the traffic coding matrix computation. Basically, what we have to try to do here, but we haven't been so successful so far, is to solve what is called the inverse problem and try to obtain what is the traffic of the car or origin destination matrix for a given areas. That is compatible with the measurements obtained from the sensors in the city of Bilbao. In this case, for instance, as I previously noted before, we have these locations where with the sensors, the same data we have used for the data prediction, for the traffic prediction module, and we are considering, or we have tried to do the computation for the areas in the districts in Bilbao. Now, for this combination, this is a very complex process that we have tried to solve. I can try to show you the results here. For instance, these values, we know that this is the values that we are obtaining are not accurate and they don't make too much sense. But we wanted to show what we have done. Here you can actually change the origin of the areas that you want, and it's going to change the color scheme in the map. More darker where more trips are happening. So in this case, we are choosing the trips that are starting in the area code number 7, and you can see that most of the trips are going to the city center. We can change the trips that are starting in the city center, and now again the darkest area is the one with more trips ending over there. You can also change if you want to specify the destination and so on and so forth. Um, Also interesting here, important here is to note that here we have the exterior area is denoted here by this square over here. And these are all the data analysis tools that we have developed for the case of Bilbao. If you have any questions or comments, you can get in contact with me. Thank you.